Hello friends. So in continuation with previous video, we are going to have GATE 2025 forenoon session question paper, and this question is like this: a square footing with base of footing at 2 meter depth and size 6 by 6 meter and 2 meter thick of concrete has a point load of 2400 kilonewton acting on it. Find the factor of safety with respect to soil bearing capacity. The given data are NC 5.7, NQ 1, N gamma 0. The cohesion parameter C equal to 30 kilopascal, and unit weight of soil gamma is given to you as 19 kilonewton per cubic meter, and the groundwater table has no influence. That is, the groundwater table is very deep. Use Tarjagi's bearing capacity equation. So this problem, we have to find the factor of safety. So to find the factor of safety with respect to soil bearing capacity, let's see this problem. So you have a footing, and this is 6 meter by 6 meter. This is made of concrete, and gamma concrete is given to you as 24 kilonewton per cubic meter. The load is transferred, and that load is given to you. The transfer load is 2400 kilonewton, and the soil properties C is given to you as 30 kilopascal, and the unit weight of the soil is given as 19 kilonewton per cubic meter. And the groundwater table is very deep, so it has no influence. So here NC, NQ, N gamma, everything is given. So let us see the solution. So here we can find out for this particular footing from the soil properties. The soil bearing capacity can be found out as the ultimate bearing capacity for a square footing it is a cohesive soil. C is given, phi is 0 here, and therefore N gamma is 0, NQ is 1, and NC is 5.7. So a square footing is resting over cohesive soil bed. Therefore, the ultimate bearing capacity as per Tarjagi can be found out as QU. The ultimate bearing capacity is given as 1.3 times CNC plus surcharge Q. The surcharge is to be calculated at the base of the footing here. This is Q, and the depth of the footing has been given as 2 meter here at 2 meter depth. So you can easily find out from the depth of footing being 2 meter and gamma being 19 kilonewton per cubic meter, the surcharge at the base of the footing Q times NQ plus 0.4 gamma B and gamma. Now n gamma is given here as 0. So n gamma being 0, this term becomes 0. So what you are left with is only first two terms. So let us substitute the value, or the ultimate bearing capacity Qu is 1.3 into 30 into 5.7 plus Q is going to be gamma times D, and NQ is given to you as 1. Therefore, the ultimate bearing capacity can be calculated very easily. So if you calculate, this gives you 260.3 kilopascal. Now, therefore, the net ultimate bearing capacity can be found out as the ultimate bearing capacity minus the surcharge. So it is going to be 260.3 minus 38. This is 222.3. So QNU is the net ultimate bearing capacity. Having got the net ultimate bearing capacity, you can find out the safe. Therefore, the safe bearing capacity is given as Q safe therefore safe bearing capacity is given as net ultimate bearing capacity divided by a factor of safety F plus gamma into dF. So the net ultimate bearing capacity we have calculated here as 222.3 divided by factor of safety, which you need to find it out. So you will have to find factor of safety with respect to soil bearing capacity, plus gamma dF becomes 19 multiplied by 2, that is 38. Now, this is from the properties of the soil and shape of the footing, all the bearing capacity factors, we are in a position to find out the safe bearing capacity. Now, what is the load given? The load is going to be 2400 kilonewton. Therefore, intensity of loading, that is going to be the external load plus the load due to this concrete footing. This is the concrete footing. So your concrete footing will also apply the load. So load due to self weight of concrete footing. Therefore, load intensity, the safe load will be 2400 divided by the area. Area is 6 meter by 6 meter, that is 36 square meter. So the external load through the column is 2400 kilonewton divided by the area of the footing is 36 plus the load due to self weight is also to be considered. That will be the unit weight of concrete gamma c multiplied by 2, that is the 2 meter thick. The thickness of the concrete footing is already given in this problem, and that it is going to be 2 meter thick. So that you will have to take as 2 meter. 2 meter thick of concrete. So it is going to be into 2. And this is going to be 24. So 24 multiplied by 2. So this terms becomes 48 kilopascal. So let's calculate now. Q safe is going to be 2400 divided by 36. This comes out to be 114.666. So you can say 67 kilopascal or kilonewton per cubic meter. So due to the loading, what is the safe load that you have applied is already known to you. Now, what is the safe load that we have calculated? So here, from the soil properties, this was the equation. So substituting this value of Q safe in 1, so substituting this Q safe equal to 114.67 kilopascal in 1. So here, if you substitute it, we get 114.67 equal to 222.3 divided by a factor of safety plus 38. So if you simplify, you will get the factor of safety, or F equal to this one 222 point this you can take it this side. So this becomes factor of safety becomes 222.3 divided by 114.67 minus 38. So let us calculate 114.67 minus 38 multiplied by 222.3. This is giving you the factor of safety. So therefore, the factor of safety equal to 2.899 This is the answer. So, find factor of safety with respect to soil bedding capacity. We have been able to find it out. This is the problem of shallow foundation on bedding capacity that has been asked this year. And I hope you have understood. Let's go to the next problem now. The next problem looks like this. The next problem is in the given plasticity chart, classify soil X. Classify soil X. Figure is given. So here it is like this. This is liquid limit on the x-axis and the value of plasticity index in percent on the y-axis. This is 20. This is 35. This is 50. And this is the A line. So in the plasticity chart, you have got the A line. So as you know, if the liquid limit is less than 35 and the point lies above the A line, then it is going to be Cl. Between 35 and 50, it is going to be Cs. It is Cl, this Ci, clay with intermediate plasticity, and more than 50, it is going to be Ch, clay with high plasticity. So point X has been given over here. This is the point X. So this is the point. Now here, as you can see, it is above the A line. Naturally, it is clay. Now, because liquid limit is more than 50%, so it is going to be clay with high plasticity. So it becomes CH. So clay, it is definitely a highly compressible clay soil. So highly compressible clay. This you can classify it because the LL is greater than 50% for this X, that given point, and also above A line. Therefore, it is going to be highly compressible clay. Next problem, we can see it, which has been asked in GATE 2025. So that we will also see. So this problem is, if the initial water content of a soil, if the initial water content of a soil is 18%, 18%, and degree of saturation is 65%. A specific gravity of soil solids is 2.74. Then find the water content find the water content in percentage of soil when degree of saturation will be 82%. Assume there is no change in the volume of the soil. No change in the volume of the soil. So let's see this problem. Let's see the solution of this particular problem. So the data are given to you. What is the data here? First, you can see the initial water content of a soil. So initial water content W is given to you 18%, that is 0.18. Degree of saturation, that is SR, equal to 65%, that is 0.65. And a specific gravity of soil solids, GS, is given as 2.74. Therefore, you know the relationship that E into SR equal to W into Z. Or you can say E equal to W into G divided by SR. Now W is 0.18 and the specific gravity G is 2.74 and the degree of saturation is 0.65. Therefore, you can calculate the void ratio. So, void ratio is very simple, Wg upon SR, and Wg, let's calculate 0.18 into 2.74 divided by 0. So the value of E therefore is 0.7587. This is the void ratio. Now, because there is no change in the volume, so the solid part and this is the volume of the void. This will remain unchanged. There is no change in the volume of the soil mass. So void ratio remains same. Then what we have to find? We have to find the water content of the soil when degree of saturation would be 80%. Now, when you make the degree of saturation equal to 82%, that is SR equal to 0.82, what will be the value of moisture content or water content in percentage? So E into SR equal to W into GS. This implies that 0.7587 into 0.82 SR value equal to W. This we have to find out. Find the moisture content or water content multiplied by GS, which is already known to us, 2.74. Therefore, we can find out. So, on simplification, therefore, the water content at a degree of saturation equal to 82% is going to be calculated now. So, on simplification, 0.7587 multiplied by 0.82 divided by 2.74. So the moisture content in fraction, it is 0.2270. That is, it is equal to 22.70%. So the value of moisture content here, find the water content equal to, this is the answer. Friends, with this I have solved all the problems of GATE 2025, both of forenoon session and afternoon session paper. And I hope that you will give your feedback. You will be benefited from this all information. And the next video will be based on questions asked in engineering services examination. Thank you very much.